Yes, this is water, which we're really thankful that styrofoam is not dissolved in water, because then how would we carry our drinks, right? Yeah. So it's a good thing, all right, that it doesn't dissolve. But the problem with styrofoam is kind of just what you just said, right? That it's not recyclable. Okay, so can you imagine all of this going in the waste container and just sitting there, So we have advantages of making polymers, okay, like sodium polyacrylate. Yes, it's a good advantage. But then we also have some, problems, okay, with polymers. One rule that we learn a lot in chemistry as we go on is like dissolves like. Okay, so if there are two things that are similar to each other, they will dissolve each other. Okay, so this is what polystyrene is, this structure, and that is acetone. Okay, so they have similar structures, as in they both have carbons in them, and so they dissolve each other. Okay, this one. Now, before we go on to this one, though, I wanted to show you one little thing more. Okay, to kind of show you how chemistry is coming along. Okay, so this is styrofoam. Okay, still, this is also styrofoam. Okay, but I want you to see the properties of this. And this one, no mystery. I'm going to add water. Okay, to both. I need another break, so. Okay, the back. Come forward. Okay. So you can take this out and feel what it feels like. Nothing's going to harm you, otherwise I won't have you touch it. Okay. So, yeah, got the good feel for it? Okay, good. Then go ahead and feel the other one now, this one. Does it feel the same? No. Is it getting squishy? Looks like Cheetos too, doesn't it? Okay, well take one and squish it. Take one and squish it. Is it squishing? Yeah. Does this one do that? No. So which means the properties are different, right? Thank you so much. Okay, you want to wash properly? A little bit more? You're okay? Thank you. Okay, so she proved it for me. I didn't trick you or anything like that. But this one, see how it gets mushed up? Like this? These new peanuts or packing material that they're making now, these are biodegradable. Okay, and so these ones are the old ones, these old peanuts, which are not biodegradable. Right? So now they're trying to switch everything to something that is biodegradable. Right? And so the volume also will get less, because if you can squish something, then it gets less. Okay, and volume and space also. Okay, but whatever is coming out, if you hear that sound, shout it out here. Okay, so which means that we're getting towards better chemistry. Okay, and that's called green chemistry, by the way. Okay, as we keep going to better and better processes. Okay, so thank you. There is that. Okay, so the last one that I have for you, almost last, quite the last, is this. And this is something that you have to count with me. And again, I hope it works. Okay. This is a reaction that works within 15 seconds. Okay, so we have to be good. You know what, I should have brought probably 2 minutes. So, what did you hear? Beat the water? Yeah. Okay, so I'm going to take, I think this is exactly 500. All of this, well then I will need it, I guess, because it's exactly 500. There, okay. I'm supposed to put the stopwatch on, okay, but I'm not going to do that because it's kind of have to go out to the link and all that stuff. So I want you all to count with me. Can you count 1 through 15? Okay. No date math. All right. So as soon as I mix, you have to start counting. If the reaction doesn't happen within 15 seconds, I pack up and go. Okay. 20 seconds. Then I pack up and go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
just have to put out the fire. I light the fire, you put it out. That's how we do. That's how we roll. And if this doesn't work, then sincerely, goodbye. Yeah. So, let's see if we can light the fire. Yeah, I got my goggles on now too. So, there we go. And that's water on fire. But you know it's not water, right? I did something. There we go. So what happened? Very good. If I put ethanol in water, this is what happens though. Where is my little flask? This is what happens. Can I put this on fire? Yes, most likely. Want to try it out? Of course we do. Look at that. It's kind of bigger then. No, I don't have enough.
What about this one?
I need a small one. I need a very small one. Oh, it's out. Okay. There. Not ethanol. Okay, because ethanol will completely mix in water. Okay, and the water is enough there to not make it flammable. Okay, at least not this one. Okay, but if I just had ethanol, then it would light on fire. Okay, which people do use a lot of wine and all that in cooking. Okay, and have you seen those flames? You know, they come out. Yeah, that's exactly what they're doing.
They do dessert, flambe or whatever.
Right, right, and so it just exactly lights on fire. But this was a case of density actually. Okay, and so what I did, yeah, my little trick here was to use a compound that was not soluble in water, because now it's all gone. Okay, so it's not soluble in water, which ethanol is soluble in water, so it's not a good idea to use. The other thing was that it should only be on the surface of the water, okay, which means that it should be lower or higher in density than water. Lower. Okay, you saw my face, right? Okay. Yes, it should be lower in density so it can float on water, right? Okay. You don't have to think too hard. When we have oil spills, what happens? Floats on water. Okay? And one of the ways to get rid of that is actually by burning it. Okay? And it's not a very good idea because we saw the flame, right? How big it was. And that was just like a little squirt, okay, of gas that I put on there. But can you imagine if you had an oil spill of millions and millions of gallons? There's so much of carbon dioxide in the atmosphere. Okay, so not a very good way of cleaning up. But guess what? You remember the sodium polyacrylate? The diaper substance? We make the same kind, but that is going to be now hydrophobic. That is hydrophilic because it absorbs water. But if you make it hydrophobic, it absorbs oil. Okay, in it. You can make powder like that too. So that is, some of the advantages of chemistry that we have. And hopefully the magic was real for you. Was it real?
Yes.
It was. Okay, very good. That's all I have for you. Thank you so much. Do you have any questions you would like to ask?
How did that change color?
How did that change color? Yeah. There are actually two chemicals that are mixed in there, obviously. Those two chemicals are also not just two chemicals, they are solutions made of 3 or 4 chemicals.
Oh, okay.
And so after a while, the chemicals are released, and when they're released, it changes the color. Huh? Can you guess? Sure. One of them is starch and one of them is iodine, right? Yes. The rest of them are there to support. Starch.
Yeah, I got one too.
Good guess. Any other questions?
We have 4 more